God. So, my fellow female engineers, political talk, but we're going to talk about DevOps. So let's get into it and talk about what is DevOps. So first of all, I want to kind of check the levels. How many of you are software engineers? Raise your hand. All right. How many of you are cloud or DevOps engineers? Nice. Okay. So how many of you know with a very clear definition of what DevOps is? Oh, nice. Okay. So I will not bore you with the official common definition of DevOps because I don't like it. So I'm going to give you my definition of DevOps, which is much more simplified and kind of to the point, which is DevOps is everything, which means the tools, technologies, concepts, principles, people coming together and talking to each other, people collaborating with each other, basically anything that you can imagine that serves one purpose, which is taking what developers created and developed and bringing it to the end user all the way to the final user of that application as fast as possible. Which means, right here, you see the pipeline. How many of you know CI/CD pipeline? Yep. Awesome, I like that. So, CI/CD pipeline or application release pipeline has many steps. And as software engineers or even cloud and DevOps engineers, you guys know that some of these steps have sort of bottlenecks, right? So that means anytime that between those steps there is a delay or there is something blocking that progression, so to say, to the next stage, is what DevOps should dissolve and solve. And what are those blockages or those bottlenecks? Anytime when a manual thing has to be done, a manual step needs to be taken between those stages, those steps, that is basically introducing a bottleneck. So let's break it down a little bit and see how this can be streamlined. So again, not to forget DevOps definition, anything that removes those bottlenecks, those manual efforts in between those stages is part of DevOps principles or part of the DevOps purpose, right? DevOps goal. And because of that, at the very core of DevOps is automation, because we want to remove those manual steps and manual efforts between those stages. We want to automate everything and streamline it. And because of that, the goal of this talk is to make you all want to become DevOps engineers.
It's brainwashing.
So, exactly. So let's, I'm gonna start scribbling over here because we're gonna expand a lot on this stuff. It's great that you guys know about CI/CD process because CI/CD also happens to be the backbone of DevOps and kind of where everything else builds on top of it or extends on it, right? So we start with the Git commit, and then we have test. This is a very important stage, especially in DevOps. And then we have the build, and let's say pushing the build to the repository. So yeah, let's say push. And then we have the deploy. So I'm going to stop at deploy here before talking about the different stages. So the most clear, the most obvious bottleneck in this process is tests, right? So how many of you know projects that have completely automated tests of the code changes that you just made, that basically you're like, we don't need a manual tester, we don't need a test engineer who will test the changes, so we can just be confident about our test coverage and just push it to the next stage, which is we just package and build our thing and put it in the artifact repository and it's ready to deploy, even to the development stage, which is the very first stage, right? Good.
I love test-driven development, that's why.
Nice. Very good. In practice, a lot of companies cannot achieve that because of various reasons. The most important one is business-driven reason, because usually the incentive is on creating new features, fixing the problematic bugs, but mostly companies are not thinking about test coverage and testing the code and everything, because that's where the engineers have to kind of push and say, hey, we need tests, because every time we create new changes, things break, and then we have this manual effort, or we have some horror stories in the production, right? So this is the first stage, basically, that DevOps principles or DevOps processes should automate and remove as a bottleneck. So we have the thing here. Very often we have testing after we build and package the application, right? Because we may have the code tests here, so functional integration tests and so on, and we may have you guys know Docker containers. When we build and package an application in a Docker image, then we may also have tests that scan the Docker image for any issues, any performance issues, security vulnerabilities, and so on. So you may have tests in between. And we get to the part where we deploy to dev. And if you know, there is in CI/CD the CD has actually two definitions: continuous deployment and continuous delivery. And one of them is till here, and the other one is till here. Because automating this pipeline all the way to the production environment is very, very difficult, because this one kind of misses those steps, but you have tests here, because after you deploy to the dev environment, obviously you need to test your application in the running environment, right? This is just code testing. This is basically testing that your code is written properly, the functions are working, and they're giving you the output you expect, and so on. Here you need to test that your application is working in the running environment. Here you need to test your application is also working in staging and it's also working in production. And very often there is a huge bottleneck here, a blockage, where someone's like, nobody touch the production, because there needs to be a list of checklists and things that need to be confirmed, and someone very high in the organization or a manager needs to manually trigger the build to deploy to the production, because and then everybody's like very alert, because it's a huge deal. And because of that, even if you have the automated process, the CI/CD till here, that's already a big deal for a lot of companies. And then moving to the other stages is also kind of the next steps. So I'm gonna write here, deploy to dev, deploy to staging. Some companies or projects also have 4 stages, like you have test, and then staging, and then you have prod. And the main reason for that, obviously, is because you get to see this. I mean, except for my horrible handwriting. Because we want to deploy the application in stages, at every stage we basically test additional aspects of the application. And when we go to the CD part, this was a... Who am I? Let me introduce myself. Who put these slides together? So, focus back on the All right. So when we get to the deploy part, that's where things get more interesting, and then we go to the realm of things that technology that I love the most, which is Kubernetes. Yes.
Is it possible to move everything a little bit to the left? Because
Let's
I think
see.
some folks on the side cannot see. I mean, I can barely see the thing. I wasn't sure. This is what I meant.
Okay. But thanks for.
Because now we cannot see the thing.
All right. Okay, let's leave it like that. Exactly. So that's where we get to the Kubernetes environment. Who here loves Kubernetes? Come on, guys. This is awesome. All right. I'm gonna ask you at the beginning, at the end as well. So we have the Kubernetes, and Kubernetes is a platform that needs to run somewhere. And Jackie gave us an amazing talk on cloud and infrastructure, which is underlined here, and that's where things get even more interesting with all the other concepts. But before that, I saw a slide after that I want to introduce. Great timing, right? who am I and why am I talking about DevOps? So basically, I am a software engineer turned into a DevOps and cloud engineer because I just found a great passion in Kubernetes and DevOps and all the other technologies. And 4.5 years ago, I took my notes, my research notes from working with Kubernetes, basically a knowledge that I collected very painfully through very challenging project, I would say, where I was a Kubernetes administrator. And I took those notes and I saw a very high demand for Kubernetes and a lot of engineers who didn't like Kubernetes or didn't understand it or they found it challenging. So I started creating videos about Kubernetes technology, like a whole playlist, with the Docker and Kubernetes videos. And that series of videos turned into a channel. Where is it? Tech Rolling. No. Thank you very much. And this February, actually, we surpassed 1 million subscribers, which still is a shock for me because I never would expect that 1 million people would be interested in DevOps and cloud in general. And the cool fact about this is that we are officially the biggest DevOps and cloud channel in the world, run and founded by 2 female engineers. Thank you very much. So this is my co-founder Nicole. She doesn't like Kubernetes or DevOps. she was actually a front-end developer, React developer plus Java, but she was like she was a senior React developer actually. And when I started creating those videos, me and I basically saw an opportunity to turn this into this huge community and a business. And right now we are doing this full-time, basically not only creating educational videos, but also training engineers at companies. I even trained NASA engineers in Kubernetes, which is still a shock for me because it was crazy when they asked it, but it did help with my imposter syndrome a little bit. And other companies followed because of our exposure, and that's basically what we do. Right now, we are on a mission to educating people in DevOps, and obviously, both our goals is combined effort to get more women into DevOps and cloud engineering because we are missing a lot of female power in this field, and it is extremely exciting. It is awesome field to get into. It may be scary and very intimidating at the beginning, but it's awesome once you get there. By the way, I have a video on the channel, Is DevOps for Me? So you can watch it and find out if the DevOps is for you. And we do that obviously with YouTube, but also with DevOps Bootcamp, DevSecOps Bootcamp, IT Beginners course, all the other stuff. So that's what we do full-time, and that's why I'm standing here presenting DevOps to you guys. Yeah, let's get back to the DevOps. So all these concepts, obviously that you hear, these are not DevOps specific, but because they, again, serve the purpose of DevOps, which is automating everything, removing the bottlenecks from this fully streamlined pipeline, these are part of DevOps. So these are the technologies that basically help DevOps to implement those things. And we're going to talk about this in a very flow-like manner because I want you to understand the conceptual side of these technologies, not just technologies themselves. So,
it's me again.
Yes.
Can we move because people cannot see the right side of this. We want all of the great content.
Very good. Is it fine now? I can.
Yeah, this is great.
Thank you. Very good. Awesome. Right. So, first of all, as I said, at the heart of DevOps is automation, which means everything is code. Have you guys heard of the concept X as code? Basically, everything is code, infrastructure is code, configuration is code. So the concept of everything as code means that you are automating things instead of manually writing some scripts and executing them from your local computer and then creating some environments. Everything is in code, which is everything is capable of automation. Okay, and because of that, because everything is automated, you have the opportunity to scale on different environments. So the first type of code is pipeline as code. We don't really think about it as software engineers because we have been doing it for a long time. You know, you have your Jenkins pipeline or whatever pipeline, and that's your release pipeline, right? That is pipeline as code because how many of you guys have had Jenkins jobs that were configured through the UI? A lot of projects still do that, or in GitLab, for example, or in other like TeamCity or other CI/CD pipeline platforms. A lot of time people would configure everything in UI. Now, why is that a bad thing? Because you may have multiple pipelines for a project, or you may have multiple pipelines per project and for different teams, right? So that means that you have to do that manually every single time for each pipeline, and you can really reuse anything between the organizations and projects. And when the pipeline is configured properly, it can get really complex, really huge. So you may want to make the process more efficient. That's why by default, the more recent CI/CD tools actually use pipeline as code. So you have scripted your pipeline. They don't even give you the option to do that like with UI. You have the entire pipeline configuration in code. Usually it's a simple YAML syntax. You can get some boilerplate from their documentation, but that's the default best practice approach in DevOps. You want to have your pipeline as code. The next up is going back to deployment environments. I kind of rushed to Kubernetes, but it's also important to talk about Kubernetes and why it even came about and what is the deal with Kubernetes. Really briefly explain the evolution of the environments. So you had these applications that ran directly on servers, right? So Jackie talked about containerization and virtualization, but before containers, you basically had a server, and this application, let's say it was a jar file or a WAR file from Java, and this would run directly on the server, right? So that was a monolith application. Monolith meaning, you guys know what monolith is? Monolith versus, okay. So basically it's just one code base packaged together in one file, and it's just executed on the server. Then we had this shift from monolith to microservices applications. So microservices, again, very simply explained, it's basically the same application, but broken down. The code base itself is broken down into chunks or pieces that now make up the entire application. There are best practices about how to chunk up that application. It shouldn't be technological, like front-end, back-end, but it should be business, logic-driven, like payment, card service, whatever. And those things were extremely, extremely hard to run directly on server or servers, right? Very unmatching thing. So this made a lot of things easier for software developers, but this is a nightmare for operations engineers to manage on bare servers. So a very perfect environment to run this was actually containers, because you literally have this virtual environment around each microservice. And the good thing is that because this is one server, right? You have, let's say, Linux, you have some dependencies, some packages, but what if this is a Java application, and this is a Python application, and this is Python application but with a different version? Like, you basically have a challenge of running everything on the same server. But with containers, the good thing is you have isolated environment. Here you have a Docker image that has Node.js. You have Docker image with Python. So you can develop each microservice with its own programming language. The teams can basically package any microservice from the application in its own container, and these containers can now run on a server or different servers. Now we have second challenge. So we solved the challenge of running these individual items of the microservices on servers through containers. But now we have containers running on servers, and the biggest challenge here is networking, right? How does this container here communicate with this one? Because these are two different servers, and as people got the benefits of microservices and containers, it's super easy to run. The developers went wild here, so they created microservice application with replicas and hundreds of services. So you have hundreds of containers that run on like multiple servers, and now you have connection or network issues between each one of those, right? And then you have other issues like, let's say if the container dies, or two containers die, and you have hundreds of them, usually you would have to have some automated scripts or some crazy logic to detect, oh, a container just died, so the front-end service is not accessible, or the payment service is not available. So you don't have any way to kind of manually, to automatically restart the containers. You again have the operations effort here, right? And a bunch of other things. So that's exactly where Kubernetes came in. Because Kubernetes basically said, and this is a really, really interesting concept, so you have all these servers, and Kubernetes is basically a layer on top of it. So you can think about it like it's a platform, right? So it's a layer on top of it that abstracts away all the servers, all the underlying infrastructure. In fact, you don't even care, is this Linux, is it like whatever it is, and which cloud or multiple clouds it's actually running on, right? Here you have Kubernetes, and you have the interface of Kubernetes, so you just deal with it. So this, wait. There you go. Cool stuff, right? So basically you have the Kubernetes interface, you never work with the servers, and your containers are now running on Kubernetes. And you know the really cool thing about Kubernetes is, you have the operations engineers, they have to manage the containers, deploy them, manually restart them, troubleshoot them. Kubernetes is like an automated operations engineer who is managing your containers. So what happens is you're telling Kubernetes, hey, this is my microservice number 1. Give me 10 replicas of that microservice. Kubernetes is like, sure. Here are 10 replicas of that same microservice. And then puts a server, a service component in front of it, so you don't have to configure or think about how do I talk to any replica of this microservice, like do I talk to this one or this replica? You don't care because you have an endpoint, which is a single endpoint with service. This is a Kubernetes component. Let's remove this one as well. No, oopsie. Yeah. And whenever someone talks to this, a request basically comes in, then any one of those 10 replicas is automatically selected. You don't care, you don't even notice that something happened. And another really cool thing, let's say you have 2 replicas of this, right? Because they are very resource hungry applications, and you don't want to run 10 replicas, you just want to run 2. Let's say one of them dies. Kubernetes is like, hey, no worries. I just noticed that your microservice replica just died, so whoops. So here is the same replica just relived and revived. So there you go. So, and this happens within seconds, so you don't even notice that you had a downtime. Another cool thing that Kubernetes can do, again, automated operations. So let's say you are releasing, this is microservice number 5. So let's say you're releasing microservice number 5, a new version. So this is, let's say, version 1.2, and you want to deploy, you have, let's say, 6 replicas, right? And you want to deploy a new version, 1.3. And in operations team, you usually have this issue. I have an application running, so whenever I update to a new version, I have an application downtime, or that service is not working anymore, it's not available because I have to stop the old version and I have to start a new one. I have to configure all the other services to point to the new one, and you have basically a downtime. Or you have to configure that properly. With Kubernetes, you have basically a rolling update, which is a default deployment strategy. And what that does, you have the 6 replicas here, right? So it basically, I should have taken 4. So it basically goes and deletes 2 replicas, and then it starts 2 new ones with the new version. Then it goes, deletes the other 2, and then it starts new ones. So you have that kind of a very smooth transition from the old version to the new one without actually losing or having an application downtime. And these are just a subset of cool things or automated operations features that Kubernetes offers out of the box. And that's why Kubernetes became extremely popular and kind of a standard in today's application, which was a direct evolution from Docker containers. That's why Docker and Kubernetes are often very linked together. Where people think about Kubernetes, they think about Docker, and because it kind of was an evolution from containers to Kubernetes. So that's why I'm passionate about Kubernetes and why I like it. I talk most of the DevOps talk about Kubernetes, and that is basically a technical part of how the application runs in a new environment. But we also have this non-technical part or semi-technical part where we actually have this thing, but multiple times, because when you're deploying to dev environment, this is actually a dev cluster, right? So you have a dev cluster, and what's this? Hello. So you have a dev cluster, and then you have this. Another color. And then you have a staging cluster. And that's it, pause. Kubernetes. And then you have the production prod cluster. And there is a best practice about different deployment environments in DevOps, which is they need to be almost identical. Because there is no point of having a development environment or development cluster and running all the tests here to make sure that your application works in the runtime, and then deploying that application to a completely new environment, because why did you just do the testing? Because that doesn't mean that it's going to work in the staging or production. And that's why when you do testing here, it needs to be almost the replica of the staging and production with maybe very, very marginal differences to make sure, to give you confidence that, okay, this has passed all these tests, so we can deploy it into another stage and then into another stage. And the biggest challenge, if any of you has dealt with replicating the same Kubernetes infrastructure or Kubernetes deployment environment 3 times is, so let's say, this is actually from my experience, that's how I started with Kubernetes. We were deploying the Kubernetes cluster on bare metal servers. So what we did is we created a Confluence page and we copy-pasted all the commands that we executed on this server with some notes, and these were obviously some, from documentation and from some Stack Overflow, not recommended, some Stack Overflow commands, some notes, like this command didn't work, so I had to tweak it a little bit to add and adjust this. So basically all of this documented here, and then we set up the development cluster with lots of manual configuration, of course forgetting to document a lot of it, and then it was time to create a staging cluster. So you can imagine how this went, right? So I opened the Confluence page and I started to replicate everything, and it didn't match, so to say. It was a completely different environment because it was like, something is missing here. Or in most cases, those comments didn't work because by the time we went to setting up the staging environment, these were deprecated or they just updated or changed the repository. So half of these comments just didn't work. So that's where, well, let's see where we can slide for that. Let's see if the order of slides. Okay, we talked about that. Yes, I got it right. So that's where the infrastructure as code comes in. Why do we need infrastructure as code? There are multiple use cases, but this is the one that, for me, highlights the most the value of infrastructure as code, which is you don't have the Confluence page with outdated stuff, but rather you have a let me see. Oh, you know what? Let's. Okay. Come on. Okay. So now you don't have a Confluence page. You have a code, right? You have a code base, basically a script that defines what you installed, in which order, what services you installed in the cluster, what services of AWS you configured and connected to the cluster. So basically all of that is documented here, but in an executable format. So once you are done with this documentation, because code itself is a documentation, you can literally just go here and be like, okay, so I have a blueprint here of the environment, which is, let's say, a dev environment. That's what we're creating. And then once you create that, once you execute that with one apply, you have the dev environment. And then you tweak maybe a couple of parameters. Maybe you open, like, I don't know, different firewall rules, or you make some adjustments. And again, with one click, you have a staging cluster, right? And then you have a prod cluster. So you have the same blueprint, and you can execute it to create the same exact environments. And infrastructure as code tools, you guys know the most popular one? Terraform. Yes. So Terraform is also an awesome tool. And Terraform has its own language, so to say, which is very simple to learn. So you don't have to be a coder, and that was actually created by purpose because most of the people who would use Terraform and who would actually document or create the blueprint for infrastructure, at least back then, were operations engineers or DevOps engineers who didn't do coding. So you could just give them a JavaScript or Python language. So this is basically a DSL for Terraform, which is very easy to use. And everything is packed into modules. So you have, let's say, EKS module that basically creates or gives you a Kubernetes cluster on AWS, but it allows you to create the entire environment on cloud because, as I said, Kubernetes runs on a cloud infrastructure, right? So you have the infrastructure, AWS, Azure, whatever cloud you want, and then on top of that, you can install Kubernetes, and inside Kubernetes, you can also install services because the thing is, as much as I like Kubernetes, when you install even if you set up a managed Kubernetes cluster like EKS, for example, the default is not usable for production, okay? The defaults that you get, it needs a lot of tweaking, right? So you have to, even if you enable the networking plugin and all this other stuff, you still have to install third-party or external services on top of it to make it production ready. And those things you can also define in Terraform. So basically here, you're building this end deployment environment with cloud platform, Kubernetes on top of it, even data, backup, storage things, the Helm charts that you want to deploy, the services you want to deploy in Kubernetes cluster. And once you are done, so basically you test everything and you have a working cluster, you take the blueprint, you can replicate those environments. Now, let's say we have a junior engineer in the team, and he messes up our dev cluster. He does kubectl delete all or something like that.
Fire
So we don't want to fire him, but we want to use it as lessons learned, right? So the good thing here is that we can take our dev cluster that our engineer just messed up and destroyed. Of course, it's gonna leave some lines here, and we can use the same blueprint, and we can do like Terraform apply, boom, and we have our dev cluster again. With the services and everything that we deployed, and we have it in minutes. So operational load of managing the infrastructure, managing Kubernetes on top of it, managing the services inside Kubernetes, and everything around it is basically reduced to absolute minimum because everything is kind of combined and compressed right here. That's why Terraform or infrastructure as code tools are perfect for operations engineers to automate. Again, the automation is the key here, to automate and kind of streamline this process. Right, so let me delete this part as well. All right. So that's where infrastructure as code comes in, and let's say what we have. Okay, let's skip the configuration as code because we can do most of the stuff with Terraform as well. And this is a very interesting concept. So kettle versus pets. The servers that I mentioned before, where it had this environment, or even the cluster that we built with Confluence documentation, basically you are creating this, or back in the day, you would create this dev environment, and most of the things were configured directly on the server. So you would connect or SSH to the server or the servers that made up the dev environment, and you would run some commands and some scripts copied from the Stack Overflow or some forums. And you would basically, every single day you would do some configuration, and probably you wouldn't even remember what you did here. You need to document half of it. So this was basically a server that was running something, but nobody could touch it, even not you, because nobody knows what happened here. You don't have a history. You may have a history, but outdated. And basically you don't know, or nobody's allowed to touch that server, because if somebody touches it, especially a DevOps engineer, a junior engineer, something may get messed up here. So with this here, so let's say we have a dev cluster with, let's say we have 100, no, let's say we have 20 servers here, right? No. And let's say here we have 50 servers, and here we have 100 servers. Now imagine with 100 servers, you had to manage each one of those 100 servers like it was your baby, like nobody touch it. We have configured some crazy stuff there, and you may mess up something. That would be completely unrealistic, right? So the concept of kettle versus pets means that kettle, basically, you have 100 servers, so you don't care if 10 of them just fail, right? You don't care. You have an automated system that basically brings up those 10, or even if those 10 fail and no new servers get added, you still have everything still running here, because again, Kubernetes will schedule those pods on other servers. So no one server in this cluster has any meaning to you, because the entire thing as a cluster, the concept is what runs the application, like this your dev cluster or production environment, but the individual servers have zero meaning, or they're not meaningful to you. So none of them gets configured in a way that nobody can touch it, but rather if they get removed, or even if the entire cluster goes down, you can basically replicate and reproduce everything. And that's the concept of moving towards kettle. So we want kettle, we don't want pets. And what? I don't know what that is. Let's switch. That's what I want to talk about. So now this becomes even more interesting, because now the question that you have to be asking here is, so this is a code base, right? So we have a junior engineer joining the team, the DevOps team, and now he needs to configure something in the dev cluster, right? How does he do that? Do we allow him to connect to SSH into one of the servers? one of the control plane nodes or worker nodes in the cluster and execute some kubectl commands, or even connect to the AWS cloud account where the cluster is running, and make some changes there. So basically the answer is, it doesn't matter if junior or senior, the best practice, the one that we want to move towards to, is no human user is ever touching the infrastructure or Kubernetes or anything ever. And in Kubernetes, the good thing is, or in Kubernetes and AWS, you can actually, instead of scolding people like, why did you log into the worker node or control plane node and did something there, we can actually configure the entire access management so that nobody, even the admin, does not have any permission to change anything in the cluster. So you have, for example, when you're creating the EKS, and you can do that, by the way, with Terraform, because here you can define IAM roles, and you can connect it with Kubernetes. Actually has access management system, which is called RBAC, so role-based. I'm not going to bore you with those, but you can basically connect those, and you can say, you have admin roles in the cluster, and you have developer roles, and both of them have completely read-only permissions. So as an admin, I can see in the entire cluster what's happening in the kube system namespace and everywhere. Developers can only see in their application namespace, but no human user can actually ever touch the cluster and change that. So somehow it needs to be changed, right? And that's where the only source of change is actually a pipeline, right? So now comes an interesting concept. So we have a pipeline of Terraform. Infrastructure is called pipeline, where we have a code base which is checked in Git repository, and this is where we give our admin and junior developers access to. So we're saying, hey, you can create a feature branch, you can do your configuration here, and then once you're done, junior engineer, you can create a merge request. So someone senior basically will review it, and when we merge it back into the main, this will trigger tests, some preview of what happens if those changes get applied. Are we destroying everything? Is everything fine? Maybe some security checks and so on. And after those, it gets applied to the dev cluster. And that's the only way how a cluster change can be made, by someone checking out the code, make some changes in the feature branch, someone doing a peer review, then merging it, running all these tests, and then finally basically applying the changes to the environment. And then you can do the same thing as with application. You can deploy or apply those changes in stages. You can do tests here, and then to staging, and then to prod. And that concept of taking infrastructure as code and treating it as application code is GitOps. So basically, this thing is familiar to software developers, right? You guys know how to how the pipeline works, but this was not a way the operations engineers worked, right? They never used Git repositories. Basically, everyone had their own script on their local laptop, and they would connect their SSH to the server and do some commands there. So GitOps was basically a term to teach the operations engineers or DevOps engineers from operations background to work like software engineers and basically introduce all the concepts that software engineers are working with, like Git workflows, CI/CD pipelines, automated testing of their changes into their operational side or the infrastructure management side. So that is GitOps. Any questions, by the way? No questions? Yes.
So what could the tests look like in this case?
There are, so for example, Terraform has, I think it's an open source project that basically tests, you can do a lot of different tests. So it tests the correctness of the configuration of, what was it? Yeah, configuration of the Terraform, like the syntax is correct. There is also Terraform tester that checks for security issues. So for example, if you're opening a port SSH or 22 on a server, you can configure it to fail the pipeline, saying, hey, something is wrong here because some security check. So there are, that's a good question actually. So there are different open source projects for different tools that test that specific tool. Just like there are, for example, for open source projects for testing JavaScript code and Python code for different aspects and stuff. Any other questions? I need water. Yes.
What would be an example of the differences between a dev server and a test server and a staging and what?
Ideally, there should not be any
Very
difference.
minimal, but like, what would you consider acceptable differences?
For example, the dev server can be smaller because let's say you don't want to spend so much money on the resources and number of servers. The production server, the production environment may be replicated across multiple regions, for example, or you may even have multi-cloud because AWS has a fallout and you are backing that up. So this kind of differences that basically make the production. But other than that, like in terms of workload and configuration, ideally it should be identical because otherwise you always have the risk that you didn't test something in dev and staging that is going to pop up in the production. The good thing is with Kubernetes there are actually different deployment strategies that even if you deployed something buggy to the production, you can do it in a slow like transition so that it doesn't mess up the entire cluster, but you have a way to kind of revert it back. They're like green-blue deployment, and for example, you can do deployment where you deploy a new version of an application or a new version of the infrastructure changes, and you basically send only 10% traffic to the application or anything that is affected by the change, and then you test that 10%. So everybody else gets the old access, and that's how you can minimize the risk. All right. Barbara, how much time do we have?
Let's wrap it.
As long as I want.
Yes, but let's wrap it up, but no rush.
So 1 minute?
5 minutes.
All right. Let's see. Okay, that's what we talked about. Yes, DevSecOps. So that is the last point. And this is also a very interesting, it kind of ties to what you asked. So let's zoom in here. Who of you knows the DevSecOps concept and what it is? Plus points, Barbara. So DevSecOps is a new term, and very important to kind of differentiate is that DevSecOps is actually DevOps. There should not be any difference because the security, so this thing in the middle stands for security. Security is implied in DevOps, but people didn't really grab that message, and they were like, who cares about security? And that's basically caused the DevSecOps as a separate standing concept to be introduced. So back to the DevOps definition. Let's see here. If you have, let's say you are developing an online banking application, right? The security requirements of online banking application are very high, right? You have the compliance, you have to have like very strict security measurements because it's literally about tons of money, and this is where most of the hackers' attentions would go, right? So you have to protect even more. So in those applications, what would happen is that you have this entire process, and let's say right here we have the dev deployment environment, and here, in addition to the manual testers, there is a huge wall here of security and compliance team. So security people come here and say, you can't just deploy to dev, like because you just made a couple of integration tests and some functional tests. That doesn't mean that your application is good to go to dev, because let's say you don't have the dev. That is actually another difference between those two clusters. The dev may not be public, So you may just do internal tests here, but production is public. But we still want to make sure, because we want to have strict security, we want to make sure that everything here is secure, everything here is even more secure, and everything here is super duper awesome secure, right? So the security team here, right, in here, and then here you have even larger wall. Those people would say, stop, we need to go through your change, we need to go through our checklist, and we need to make sure that everything is compliant, secure, from our perspective. And that is a manual effort that blocks the release pipeline, which is disrupting DevOps. And that's why having security inside that process is part of DevOps. But it was left out, and that's why we have DevSecOps. So what is the DevSecOps solution, basically? Just as we are introducing automated tests here to make sure that we can remove the manual testing effort, we are taking all this work here that security and compliance people are doing, we're transforming them into automated security tests or security scans, right? Security scanning, and we are sprinkling those in between every stage here, right? And then here and here. So instead of someone waiting here at the end to manually test our changes for security and application and so on, we are basically putting that into our DevOps pipeline as automated steps so that we never get this big blockage of manual work, and we automate it again, at least till the development environment, but preferably to staging and then to production. So probably you are interested to know, what are those tests, right? What do we do here? What do we test, and when and why? So I'm gonna do it in 1 minute. So there are different aspects, very briefly, there are various aspects of application testing that you can do. The first one is the code base. So you wrote Python code or JavaScript code, and you want to test that your code does not allow any security issues. You know, SQL injection, the cross-site scripting, all this stuff is basically a vulnerability in your code that you wrote that allows an outside malicious actor to basically get into your systems, in your code, and so on. Code base needs to be tested. And again, there are different tools that automatically test or scan the code for these issues. Then you have dependencies. Every application is made up of dependencies. I'm writing. Yeah. Dependencies, right? You have the package manager tool, like NPM, for example, and you have all these libraries and packages that you're using. Those packages are code developed by other developers, right? And they might have made some security issues. So there's scanners, security DevSecOps tools actually, that scan your application for dependencies, and they find dependencies that have publicly known vulnerabilities, and they tell you you're using a library that is outdated, that has a known issue, security issue, you should not be doing that. And there have been a lot of large hacks in large companies because of those companies using outdated libraries in their code, this is a huge issue. And right here, you can basically test those before you even build the application. Then you have image scanning. Your Docker is a little, what image scanning? It's basically a little virtual server environment that has, again, a package manager for Linux packages and a lot of Linux packages that may be outdated, or has maybe some misconfigurations like using a root user. So you do image scanning. Then you do dust test. So these are all static tests. So you basically give a code base or dependency file or a Docker image, and you're saying scan it. But there might be a lot of security issues found in a running application, and that's where dynamic application security tests come in. And these happen, obviously, once you deploy those applications on the end environments, so on in each stage. And there are some other tools, but these are basically the main ones. And as I said, there is a tool for each type of application security scanning, and for each programming language, there are different ones. And that's DevSecOps. All right. I think there was, let me check. I'm gonna skip to the last one. Thank you very much. And by the way, we actually have a DevOps roadmap. So if anyone wants to see all these tools in like one nice overview of how they build on each other, what are the things that you need to know about in DevOps engineering, you can just either download it direct from the website, or you can just send us email on support, and we'll send you the DevOps roadmap. And that's it. Thank you very much.